Hey there, it's Max. This is Spokane Cyber Cup's BRISC challenge from year 6. And this is the second part of this challenge. So in BRISC 1, we were tasked with taking a set of instructions and executing them and figuring out what the result was. Now we need to take the compiled code and we need to take it from the byte code the machine code back to the assembly that we were looking at, or the BRISC instruction set. So there's two steps to this. The first part is taking the binary and figuring out how to split it up into proper instructions. In BRISC, all the instructions are just 3 bytes. So if you saw this character sequence, byte 1, byte 2, byte 1, we would know that this would be an add for memory addresses 1 and 2. So we need to do that for this entire program. This entire program is actually kind of big. So we don't want to have to prove that the people or the students did this, or the whole thing, but we need to know that they did. This is because the next challenge is really important for this. The next challenge is doing challenge 1 except for this entire challenge, which is like 130 lines or something like that. So it's better to script this, but I'll show it by hand, and then the act of going from hand to scripting isn't very hard. It's just some lookup tables and such. So on the actual challenge part, we'll interact with some port. Don't take too much point on what it looks like right now. And then we'll say we need to look at the disassembled instruction at index 51. And it will tell you what the particular input for that is. So you need to give the program the instruction for this in order to validate that it was done correctly. So we'll show you how to do that. So there are a couple of different ways you can do this. The first one is using a tool called XXD on the binary. So in the challenge, you are given a compiled version of this. So if you go to here, it's just a raw binary. So if we download that, it's just going to be raw binary. It's going to be kind of annoying to work with. But you could use a program like XSD to turn this binary data into hex. And once you have hex, it's much easier to read. I believe I put this as a hint as well. So we do downloads. Is it flag checker? Cool. So this gives us the hex output, but it's not very nice. So there's actually another tool called CyberChef that I briefly showed that makes this substantially easier. So CyberChef is kind of the Swiss Army knife of hacking tools. In particular, like encoding and decoding, encryption. It just has a lot of different things you can do. You can create a recipe. In this case, we don't need a very nice recipe. I literally went in the file, opened it in Notepad, copied it, and then I added the space delimiter and said 3 bytes per line. And the nice thing about this is now we have these instructions that are labeled in points of 3. So we can see that this is an instruction, this is an instruction, this is an instruction. It goes all the way down. And so it becomes a little bit easier to look at this. If we're going to do this programmatically, it also probably just makes sense to read the binary data in Python, convert it to hex, and handle it that way though. But for the sake of this demonstration, I'll show you how this works, like this. So we can see here that the first input is going to be 06050000. And if we look at this in netcat, we can see that the instruction information at index 1 is going to be input 50. And if we look at the specification, remember what this value was, it's 060500. We'll notice that input is instruction 6, and then it's 0500, or the next bytes, and memory address 5 is going to be that 5, and memory address 0 is going to be the 0 here. not too hard to decompile this, but there's a lot of instructions in there, and so it takes a bit to do by hand. So ideally, you would do this one by one, and for instance, for 106, I can't go by line. I can't go by line in here, which is annoying. So I can show the decompiled version of this. So there is a complete decompiled version of this that makes it a lot easier to deal with. So we're going to do 106. Oh, whoops. We can do index 106. And we'll get this instruction. So I assume that the index 106 actually means line 107. So if we look, what this would look like is we have num g is going to be 9, and then 0, 0. And so if we go back here, I go 0, 0, 9, 0, 0. We can see that there are several 0, 9, 0, 0s. I'm going backwards here, but you get the point. So for this, I'll copy this instruction. Maybe I was a little bit off. Okay, maybe it actually just is. Okay, so it actually is the line. It's not index. So in that case, the exit 12, 0 is correct. So now we have to go to 100. We have to do 51. The idea is that the students would do the entire thing, though. And this is just proving that they did that. And that's because you need to have the entire thing decompiled for the next challenge. But I showed you how to do the decompiling, and then I have the decompiled version already done. So cool. That's the flag. To recap, understand the specification, know that the instructions are 3 bytes long. You can look at the bytes and go back to the BRISC construction set and do that for the entire thing programmatically. You can get the hex information one way as well, using XSD or CyberChef. Cool. So I hope this is a fun challenge. I'll see you in the next one.